Hello, everyone. Welcome to this brand new episode of Corecast. I am your host, Tim.
And I'm Mikey.
This is Sahil. Welcome everybody to a brand new exciting episode of Courtcast. Before we get started, if you haven't already, do join our Discord channel. And if you're watching this on YouTube, which we do every Tuesday from at 5 p.m. Pacific, 8 p.m. Eastern, uh, feel free to ask us questions during the episodes. We can get to them. So without further ado, I guess Tim and Mikey, I recently we had discussed about this video that was put up by Roger Penrose about is mathematics invented or discovered? I thought it'd be a good idea if we were to discuss it in terms of physics. Is physics invented or discovered? So I guess can we start with kind of the difference between math and physics, and then we can delve into what does it mean to invented and discovered? Let's start with that. So
That's
I guess
Tim's
my
job.
oh Tim, okay,
Well, yeah, right.
Yeah,
go for it. Tim.
that's fair. That's fair. I, I, I think on the surface, you can kind of think like, oh, there's a lot of collaboration between math and physics, and to some extent, they all have a lot of equations. So one might think that math and physics to some extent is the same, and even through many videos, people say that the job of mathematics is to do physics. That's what some people think. But
Mathematicians don't think that though, right?
probably not. Probably not. Maybe some
That would be
physicists.
offensive to them.
I think that's true. But to me, I think, I mean, I'm not a mathematician, definitely. But math, the flavor of math is very different from the flavor of physics. Like when you write a mathematical paper, the only thing you need, in some sense, is some sort of axioms and kind of logical deductions. But that alone is never good enough for a physics paper. A good physics paper should always involve reality, experimental evidence. And so, in that regard, even though the mathematics could be exactly the same, there is something different about physics. And in some sense, physics kind of has an extra component, and that's the reality. And the truth, the truthfulness and the what's the word? So falseness of a physical theory ultimately is judged by nature. Now that's the key difference between math and physics. The truthfulness and the falseness of math can be just done through logical deduction. But physics is not like that. So in a real sense, we are not the final arbiters of truth in physics. And from that perspective, you can argue that minimally, like this fact cannot just be invented. Like you cannot just imagine something and say that it's physics, because it still has to go through this discovery process in nature to find out whether that's true or not.
Uh, so I guess are you saying that actually, so then where does math fit into physics in that context? Like you use math to propose things and nature is the arbiter whether or not those are true or not, or how do you think about that?
Would you think it's fair, Tim? What do you think? Do you think it's fair to say that I know it's almost cliche, but math is the language, and then nature is the arbiter of determining which statements are true or not?
I think that's fair. I think there could be instances where let's say imagine we write down some math equation like 1 + 1 = 2, something like that. Analogous to that in physics, and we just have such deep conviction that it is true. But when we go do an experiment, it doesn't necessarily have to obey that, right? Like it has in I think it has happened in the historical past that in physics that something we hold such deep conviction that we think is true mathematically turn out to be false. And when that happens, we just kind of go back to the drawing board and come up with like a different mathematical construct to describe the natural world. So so I think to that extent it's fair because yeah, because what else can we do? Math is just a logically consistent way of describing things. So it's kind of like our way of describing nature, right? Like I mean it's plausible that nature has a different language, but this is the best we can do.
Is it? I mean, so if we were to what is math? I don't know. I mean, gosh, I'm not qualified to even address this, but I mean, to me, when I think of math, I just think of logically consistent systems.
Yes.
So if you assume that the universe is also a logically consistent system, then presumably it should be describable by some kind of mathematics. And if you don't think that the universe is a logically consistent system, then I guess all I can say is that no. All I can say is that you have 1,000 years. I don't know, several thousand years and worth of evidence going against you. Yeah.
Huh. But tying on to that, like, so you mentioned the word consistent. Like, what does consistent mean in this context? And then there's something about like incompleteness, like consistent and complete. Oh, I don't want to.
All right, let's the incompleteness is way crazier than.
Yeah,
Okay.
it's way crazier.
Yeah. I mean, I think actually something I want to talk about in the beginning too. Like, I don't know. What do you guys think? I think like maybe just at the outset, like when people talk about what is the difference between discovery and invention, right? Like there are certain ways that you could, let's just kill the most like straw man argument first. Like when some people think about an invention, right? They think about like just making stuff up like willy-nilly, right? And that is not the kind of invention that we're talking about. You have some people who think that like, oh, like maybe I can just ignore everything that's been done before in mathematics and physics and come up with something new that no one's ever seen before. It's like a pure act of creativity. And, for better or worse, neither math nor physics works this way, right? Because as we mentioned, physics is typically written in the language of mathematics. And the language of mathematics does have this property that we call consistency, which is the idea that certain statements have logical consequences in the form of corollary statements, what we call corollaries. And so it kind of builds like this logical structure, this web of like self-consistent facts. Oh gosh, what's a good example of this, Tim? Can you help me out?
Yeah, I think that's gravity, right? Like if you look at the laws of gravity, Newton.
No, math. Like logical consistency in math.
Well, yeah, I mean, Newton is saying that if the laws of gravity is described by one equation, then what it means is that let's say the fact that the apple falls to the ground would have to obey the same laws as the fact that the Earth orbits around the sun. And indeed, that is true, right? We tested it experimentally. But then this logical consistency check, it's not obvious, right? It's non-trivial. Like the Earth could have orbited the sun in a different way. They didn't have to obey the same equation. But then maybe when that happens, we'll just find like a slightly different flavor of logically consistent framework to talk about it. But still, ignoring all that, like every statement about every experiment that has been done kind of goes through this consistency check, right? Like two very different things that seemingly has no relationship. It's because when we build these mathematical models to describe the world, they're related. And then we check that they are indeed related. Then it means that they're logically consistent. I think that's what Mikey is referring to here, I think.
Well, no, actually, that's the physics version of what I was trying to say. Yeah, the math version. Okay, the easiest version of like a math consistency is like if A equals B and B equals C, then it follows that A equals C as well.
Right.
Just
yeah.
by the definition of what it means to be equal. And as Tim mentioned earlier, like, of course, this rests on the fact that something called equal exists. But if you define some notion of equality, then it follows that A equals C. And actually, Tim's example of like the gravity affecting planets and apples is kind of similar to that, right? It's like, if you assume that this thing is applying everywhere, then it should affect this body the same as it affects this body. And that's kind of like the difference between consistency in mathematics, which kind of gives rise to the notion of consistency in physics.
Yeah, but I think let's just kind of prime this example to the audience. Like maybe it seems so trivial. Like if A equals B, B equals C, and then A has to equals to C. Like how can you even like deny that? But keep in mind that physics is an experimental discipline. Let's imagine we can measure this equality, right? Like we could conceivably have an experiment where we can measure A equals B and measure B equals C, But then when we do the third experiment, A might not equals to C. Like this could
In
happen.
fact, that has happened.
Like something like that could happen. So like even like you kind of have to suspend your, I don't know, logic a little bit, right? Like even when you think like your theorem or whatever mathematical system is just bomb proof, like there's no loophole, nothing, right? Experiment could still throw a wrench at you and be like, like sorry, like that was wrong, right?
It kind of sounds like Bell's theorem, doesn't it?
It kind of is. Like if you watch our previous episode, it kind of is in that way. Because every
Yeah.
time you measure something, it's kind of like you're measuring a slightly different system. I mean that's the way we rationalize it in some
Well, yeah,
ways.
no, people assumed that this like primitive notion of equality applied to
Exactly.
everything, and
Yeah.
then when they did the measurement, they realized, oh man, A doesn't equal C. That means our notion of equality must be kind of screwed up.
Yeah. So I guess we kind of have to suspend that notion first. Like even things we take for granted, it's not necessarily up for grab. Like
Especially things we take for granted.
yeah, especially things we take for granted. Like it sometimes it. Let's put it like it could be up for grabs for in physics.
Yeah.
So anyway.
So you guys are saying that basically like equality in the physical sciences, especially in physics, is tenuous. Because in mathematics, if you say A equals B, B equals C, then by definition, exact logical definition, A has to equal C. But in experiments, there's no such thing as equality
Yeah.
because everything is approximate. Is that a fair
Exactly.
statement?
I think that's fair. I think that's fair.
I wouldn't attack the notion of equality though, because that's like that's yeah.
Yeah.
Like, the Bell's theorem is not exactly attacking equality, but it's like something almost as seemingly obvious that you take for granted.
Yeah, some maybe not equality, but like something like that, you know.
Yeah.
Gotcha. So I want to move forward to the what is the difference between discovered and invented? Like, how do you guys think about that? Either Tim, you go first, or
I
Mike, you
think
go first.
I guess I can go first. I think I mean ultimately this is a very philosophical problem, right? Like who cares what language we use? Discover, invented, blah blah blah. That's just words, right? But I think in the human mind there is a little bit of difference between them, right? Like when you discover something, it feels like that something is just what it is, right? Like imagine I discover a beautiful equation, I would believe that it's not like my equation to write down. Like nature wrote down that equation. I'm just like taking a look. And when we think that hey maybe I invented that equation, maybe I would believe that maybe nature didn't write down the equation. This equation is just so good, almost like an AI that somehow takes our language and fit it to nature. In some ways, it's like some of recently we have these fantastical AI results, kind of like that are able to generate like very convincing text, right? It's almost like maybe our physics is kind of like some AI kind of that's able to generate these really descriptive equations. But of course, like which one is which? I mean, I don't know. I mean, I think physicists will have an inclination. Like, hopefully, most physicists don't think that we're just some AI writing down tentative equations. But this conviction that I think there is a bias toward that it is a discovery. Like when we see a beautiful equation, we didn't just make this stuff up. Like it really is like that beautiful.
Hmm. What about you, Mikey? What do you think about the
Okay,
difference?
so full disclosure to the audience, I mean, this is something we started talking about relatively recently, so our thoughts have been evolving on this, but I think if I'm thinking about it right now, with the hindsight of like the past 2 days, like it really seems like it's about control, right? Like if you invent something, it kind of implies that like you can do whatever you want with it, right? Versus if you discover something like, like if I invent like a light bulb, I can put a lampshade on it, I can like put it on a street, I can do whatever I want with it. It's like mine. I have full control over this. But if you discover something, like if you're like an archaeologist, like uncovering like, an ancient ruin or something, it's like that thing is already there. Like I'm not building it, I'm not inventing it, I'm not constructing it. It is just there, and I'm just like sweeping away the dirt to reveal what it is. And I think what makes those two things really different, I think it's the amount of control that we have over it. Um, so if I judge it on that sense, then gosh, yeah, physics is, I mean, we don't have control over any of this stuff. Like we're at the complete mercy of not only nature, but also of like the rules of mathematics, we have no control over how this game is going to unfold.
What if I were to take kind of like devil's advocate and talk about like the very device I'm talking to is because we're able to quote unquote like control, matter at such a small scale, so we can so many transistors into this device.
Yeah.
It seems like our approach to physics is eventually to gain control over nature as like a hubris mentality goes.
We can't gain control of the rules, though. We can learn how to play by the rules and use them to invent other things. But the rules themselves, I think that's essentially the difference between like engineering and physics, right? Like engineering is like understanding the rules, which you have absolutely no control over, and using them to invent new stuff and having control over it. But physics, at the most base sense, when we talk about like theoretical high energy physics, it's literally like we have no control. It's like,
although I think there's a small distinctions even between physical theories. There's this idea of what the theory really is telling us, and there's another aspect of a theory. It's just that the theory as a calculational tool, kind of. While they might seem like pretty much the same thing, but they're not necessarily the same in some sense, right? Like when we think of a theory as a calculation tool, it becomes more like a hammer that we invent to do these things, enables us to cook up these numbers. But when we think of theories as really kind of like something that's lurched onto the physical reality of things, then that gives you this vibe that it really is something that's discovered. And I think certainly there's a bias toward discovery. But when we look at many of these physical models, there's also this vibe that some aspects of it seems invented. So I think there's always a little mixture, a little bit of both in it, at least in my mind, for many different physical theories, right?
Would you say like, so kind of like going off the back of that, would you say that like we discover things in physics but invent mathematics to describe that as best as we can? Because like mathematics is inherently our sort of, I don't know, I haven't fully looked into this, but intuitively it seems like mathematics is invented by us. It's not something like nature kind of like put down on like stone wall and said, oh, A equals B, B equals C.
I think I would agree to some extent, but also disagree to some extent. I think the crux of mathematics, that the logical part, like the fundamental truth, it feels like discovered. But then there might be many different ways to get at that truth. Like for example, you can have like a mathematical theorem can be proven in different angles. But the fact that that theorem is true, I think it's kind of like, that's independent of how you prove it. But the route to prove it could involve many different languages and tools, and those tools and languages feels a little bit more in the realms of invented. But the crux of the logic feels more like discovered. And I think that also continues on in physics. And although in physics, to me, I think there's more aspects of it that's discovered, but still there's this tiny bit of invention involved, right? Like it's like Feynman diagrams. Like Feynman come up with these tools of calculating the probability of particles interacting. It doesn't feel like nature wrote down, like draw these Feynman diagrams. It feels like Feynman really invented it, right? I mean, he's a genius, but like even Feynman himself, I think if you ask him, he'll be like, yeah, nature probably didn't draw Feynman diagrams, right?
In a sense, it is though, because okay, I see what you're saying. Yeah, in a sense, it is at least approximately doing something like that, but it's obviously not the full story of what it's doing. I don't know. I think, what is the biggest thing that distinguishes an invention from a discovery? When you discover something, you're surprised, right? When you invent something, you're never surprised by the thing you invent, though, right? But if you look at both business and mathematicians, they are constantly surprised. It's like, whoa, who knew that could who knew it worked that way? And it always comes different from how they expect it. That just doesn't strike me as an invention, right? If it's an invention, why would we be so surprised every time we see something new?
Well, I mean, like, could you? I mean, you could strive to invent something, but like, would you be surprised that you actually did it? Like,
but they're not surprised at their accomplishment. They're surprised that it actually looks the way it does. It's like, whoa, who knew that it would look that way? It's like,
well,
this is like one of Yeah.
Maybe it's a bit of selection bias. It's like social media. We created it, and it's addicting. It just feels good.
Wait, how's that? I do not understand that analogy at
No, it's
all.
not an analogy. It's just it's just a useless comment. Uh,
I mean, that's really like the surprise at finding out what like, mathematics or nature really looks like. I would argue that among physicists, that is the source of every single exhilaration.
so,
So it's starting to sound a lot more like an archaeological expedition than some kind of like Thomas Edison thing.
but there is a flip side, right? Like we're surprised when things are right, but we're also surprised when things are wrong. And I would say whenever things are wrong, it means that some of that discovery was invented, if that makes any sense, because it was wrong. So it cannot be 100% discovered because like it's not fully correct. It's like, I mean, in terms
Is
of,
it though? Wait, I mean, if you're like uncovering some dinosaur bones and you're like, oh, I imagine that it looks like this, but then you uncover the rest of it, you're like, whoa, I was totally wrong about that.
well,
Yeah, I guess your idea of what it looked like. Oh, this is getting so meta.
right.
It's getting hard to follow.
It's like your imagination of the dinosaur was wrong. It turns out that they had feathers or like they didn't look like lizards, right? Like
So
that.
the question is physics the imagination part of it, or is physics the dusting off part of it?
Yeah.
It could be both. Maybe it doesn't have to be such a
Most certainly is, I guess.
dichotomy.
Yeah.
Yeah.
Yeah. So I kind of want to like go on the side. So we've mentioned several times with this podcast that like we believe that physics exists outside of humans. Like it's not because of humans that like physics exists. Would you both agree with that?
If it was, then we could control how it works. Like, I mean, we could control how the rules look.
Yeah. I
We have
think.
no control over the rules.
Yeah, I think most physicists would almost like 99.999, however many nines, would agree that would simply take it, as an axiom that there must exist an external world independent of humans.
Donald Hoffman might disagree, though, right?
I guess like so where I'm going with this is that like the way we observe things is like from our perspective, like the way we do experiments is from like our conscious experience. So I'm wondering like how much of the way in which we formulate physics is driven by our conscious experience. And this is a philosophical discussion. And I want to see if we can break into some elements of consciousness in here or maybe dispel that
Yeah.
completely.
Okay. Well, I would say that if this is something I don't believe, if it truly is that it's just this experience of discovering physics is completely just a product of the brain, whatever, in some ways, then of course then physics will be that by definition kind of invented by the mind, right? It has nothing to do truly with external reality. I don't think most physicists think that, but I mean certainly it's a plausibility, but it's not a very productive one. I think that's the issue. Like we can always imagine we're just kind of like in the Matrix. And for some reason, like Mike was saying, we don't have control for some reason. We can't explain it. We don't have control. We can't change the laws of physics, but we're just kind of stuck in this Matrix environment, moving along, observing the world, and inventing these like fantastical things in our head to help us survive. That's plausible, but it's kind of depressing. I don't know.
Actually, I think it's actually implausible because, like, so you could do an experiment. Not okay, you can't do this experiment, but we could one day find out the absolute truth about this, right? If there is some alien species living like 100 million light years away, and if we ever meet them, if they're like, what the hell is a hydrogen atom? What's gravity? What are you talking about? This is all nonsense. Like we have a completely different set of rules that like then we could be like, okay, so yeah, clearly everything was just an artifact of like the human consciousness. But that doesn't happen. I mean, no. We have a small scale experiment of that. Like when different cultures meet, like they still roughly experience the same phenomenons and in one person's culture, another person's culture, you could translate the language of mathematics between them and get consistent results. So we at least have some evidence to believe that like this is not just like some figment of the human imagination, but that it's something that is shared and consistent amongst people that have never met, and it's likely to be consistent amongst alien and human species that have never met. And then what does it mean to think about it as like I don't know. You get what I'm saying? I don't know.
Wait, what are no, I'm confused.
Well, I
What
mean,
I'm saying that if physics was truly just like of the human consciousness, then
Mhm.
we could meet aliens that would have a completely different way of describing the universe. Uh, and how would we even meet? Would we meet on like spaceships that are affected by the rules of gravity, or would they come? I don't know. It's just I don't
I,
know. Maybe this is.
I mean, if Sahil's scenario were to be true, then aliens would just have like physics-defying technology, just completely beyond our explanation, just like coming down on Earth and just totally supernatural behaviors, right? Like just like oh my god, like this violates all kinds of laws of physics. Like in some ways, experimentally, we'll find out, right? It would be like oh, that's
Yeah.
all BS in some ways, but like we haven't experienced that yet, not even approximately, right? I think another thing is just that physics seems awfully efficient. It's just so efficient at describing things, right? Like like Newton's law, apples falling to the ground, and the Earth orbiting the sun, is the same equation. It would seem kind of crazy that if there's some imaginary world, somehow it's so there's kind of this like this system which could technically be anything, right? It's so efficient at reusing these mathematical facts in a consistent way.
Yeah, but that's aesthetics, right?
Yeah, that is
Actually, I'm
aesthetics.
starting to wonder now. Is it possible that we could someday meet an alien race that says, no, massive bodies don't attract each other? You're crazy. There's a whole different way of thinking about this.
I I mean
Is it
like
possible? Oh, it could be.
Plot,
It's like,
me. I don't believe it, but I wouldn't discount it. I mean, I would discount it 99.9999, however many percent that it won't happen, but it's still like not totally impossible, right?
all I know for sure is that if that ever happens, my brain and the brain of every other physicist on this planet will simultaneously explode. That's all I. It'd be
yeah.
crazy.
I guess like so one thing I'm kind of wondering is like it's not that like we like make up the laws of physics or like physics is all consciousness or whatever, but the lens in which we're filtering these experiments are through our consciousness. So it's like we're kind of restricted by that. Like I mean, before people originally thought, I mean, still today even that we live in like 3+1 dimensions, and it feels like the world is three-dimensional. But there's a lot of evidence, theoretically at least, that like we're on the surface of like an area, for instance, and non-locality and whatnot. But without going too much into that, like what I'm trying to say is that like we course grain the world based on like our senses and maybe the language which we've developed from those senses in order to describe the world. So I'm wondering like, does that impact this question of like, is physics like invented or discovered?
I don't think so, because like you use the word filtered, right? It's
Yeah.
most likely true that what we experience is being filtered by the limitations of our own intelligence, if not many more things. But that means that we're still getting some piece of what's actually out there. That implies that there's actually still something out there, and we're just getting some small piece of it. Um, but shoot, what was the second part of your question?
Well,
Uh,
let me follow up. I think the evidence suggests that this is not the case, right? Because let's say imagine in a not too crazy world. Let's say physics is limited by our perception. That means if we somehow expand our perception, we'll find discrepancies, right? But that never happens. Every time we use apparatuses that kind of expand the limits of experimentation, we always find even greater agreements with our theoretical understanding. Like some good examples are like the gravitational wave detectors, some of the most precise measurement, physical measurement that ever existed. It's incredible, and it only reaffirm Einstein's laws of gravity, right? And and also some of these fantastical measurement about properties of electrons in particle physics. Every time, kind of when every time when there's an experimental breakthrough that expands our limits of measurement, we just reaffirm that conviction further. So I think this way of this definition of invention, this way of viewing what invention is, seems unlikely, right? Like physics is definitely, almost definitively, not made up in this like fantastical way.
Hmm.
But it could be.
Right, but it's not productive. I think if you say that it could, yeah, it's just not productive. Like anything could be
Yeah, like
true.
what is that? What is that? What's that theory of gnomes? You know, it's possible that everything we're seeing is just tiny gnomes. Like
Yeah,
when we see something fall, just like tiny gnomes that can move faster than you can
yeah,
see, or just moving. Like that's possible. But if you want to believe in that, go ahead, I guess.
yeah. But I think the most enticing alternative about invention is that maybe it's some really elaborate kind of AI-like system that we're just fitting our language to this world, and it could be really convincing. Like, is physics that? I don't still don't believe that's true, but I think that's kind of the remaining plausibility.
Hmm. Gotcha.
But if it's fitting to something, is that thing that it's fitting to? Is that true?
Right. I mean, that's yeah. I don't know. That's
Then it's just asymptotically reaching the truth.
exactly
And then
yeah.
and then it's still kind of a discovery. Then we're just using AI to reach it that
Right.
discovery asymptotically.
Yeah. So we're almost reaching time. I wanna say, do you guys wanna say anything as our parting words before we leave the audience? It's a kind of something to leave them with.
I don't know. For the last like 15 years of my life, I've been going back and forth on this on the topic of like whether or not physics is invented or discovered, and on the topic of whether mathematics is invented or discovered. But I think I'll settle on that they're both definitely discovered, and that invention has no part in this because I'm just taking stock of like how how little control I've had in my pursuit of anything in these two fields, and it just feels yeah, it's just they're both just we have zero control over any two of these things. How can we say that we have any kind of like invented in any kind of sense? That's crazy.
Yeah, and personally, well, I mean, I think a lot of times we come to similar conclusions, Mikey, you and I, but because our academic journeys are similar. I think personally,
Yeah.
for me, I mean, sure, discovery versus invention, who cares, blah blah blah. But as a student, when I was studying physics, like this is important personally, and this is one of the reasons why I decided to go into physics. And at some point, I was choosing between kind of like math and physics, like which one do I go into? And math, yeah, many aspects of math is very much feels like a discovery. There's a lot of surprises in there, but some of the mathematical language just seems kind of like made up in some sense, right? You build these axioms.
Axioms,
Yeah,
yeah.
yeah. That those just it does feel like invented in some ways. But of course, many aspects of math is discovered. But physics just gives me this kind of humbling aspect. Like the almost the entirety of it just feels like discover. Like you have no choice. Like, oh, you study quantum physics, you think it's not understandable, contrived, whatever. Well, too bad. Like that's nature. I don't care if you like it or not. That's just how it's being described. Like you have no choice. And kind of this feeling kind of it's humbling and inspiring, right? It's telling you that there's sometimes these greater I don't know what the right word is. Some greater existence, some like more structured, concept out there that governs us, right? And it's very deeply personal. Like physics governs us, Earth, planet, and the galaxies. And in very much and in that way, it feels like a discovery. It just so studying physics is like, you know, living through life, like just seeing stuff, finding out, right? So in a real sense, it's like I feel like a tourist, just kind of walking around, seeing these physical theory, and just fascinated by the discovery. So for me, yeah, physics is discovered. I think by
I would
and
agree with
large.
that. Yeah, I would say that physics and math are both discovered, but physics is more discovered, right?
Way more
there,
discover, I think.
there is that extra thing
Extra.
about yeah that nature arbiter that Tim was talking about. That's definitely I think
Yeah.
that's why physics is better than math.
I wouldn't go there.
It is. It's like clearly better.
Welcome to the channel, run by
What?
physicists.
I mean, some of it. I mean,
I don't disagree.
I mean, no, I'm just saying, like, who knows what we're gonna think in, like, 10,000 years. But for now, large parts of mathematics just looks like puzzles. Just looks like chess games, tic-tac-toe, like, yeah. But that's obviously just me as like an ignorant physicist who is
Right.
10,000 years too ignorant to
Hey,
understand.
but that one day when we do discover that those math are relevant for real life, they become
Then
beautiful.
they'll be the same thing.
They'll become they become more ever more beautiful. So
Fair enough. Fair enough. All right, everyone. I want to thank you for joining us, and we'll see you all next week.
yeah, see you all.